Hello kids, welcome you all. Let's discuss today's NEET question paper. Now as you know that for today's test the chapters were first halogen derivatives of alkane, second is alcohol phenol ethers and third one is aldehyde, ketones and carboxylic acid. So let's begin with the question what we have. I think so the first question what you can see is how many chiral compounds are possible on monochlorination of 2-methylbutane. Now, as such, let us write the structure first 2-methylbutane. Now, how do you write a 2-methylbutane? I think so. We have got over here a 4 carbon atom, and on a second position we have got a carbon atom. Now, this is a skeletal arrangement of 2-methylbutane. Now, the question is what? The question is how many chlorinated products can be observed. So, this compound when on treatment with chlorine in presence of light, how many products? The first thing is you can have first product as primary halide. The second option what you can have is a secondary halide. You can have the third one which is called as tertiary halide, and the fourth option you can have is the primary halide. So, how many products are possible for this? Yes, the number of products for this would be 4. But the problem with this answer is how many of them are chiral in nature. You can see that means let us write the skeleton first. So, I have put over here the first compound what you can see very clearly. Now, same compound I will select it and I will put it 4 times and then I will tell you how we will do chlorination on this. Now, next one is this. Now, again the next one is this one. I hope this is clear, child. Now, let us put one by one the cases. Now, see in the first product I think so you can have a Cl over here. In the second product secondary a Cl can be over here. In the next one I think so Cl can be over here. And in the last case the product which is primary your Cl can be over here. Yes. Now, let us fill the number of hydrogens, child. Over here I have got CH2, here CH2, here you have got CH, here you have got CH3, here CH3, next here CH3, here CH, here CH, here CH3, here CH3. Now, in this case also again CH3, CH2, CH3, again CH3 over here. In this case now CH2, CH, CH3, CH2 and CH3. Now, my question to you is what? That 2-methylbutane on monochlorination can give you 4 products what you can see, but do all are chiral compounds? No. Let us check one by one. In the first compound if you see you do not have any chiral carbon atom, that means it is going to give you product but non-chiral compound. In the second example, child, if you check this carbon atom, it has got 4 different group, 1 methyl, 1 H, 1 chloro and 1 isopropyl group. That means this gives you a chiral compound. Now, in this case if you check you have got CH3, CH2, CH3, CH3 which is not a chiral carbon. Even this is also not chiral because 2 groups are same. That means this is also not going to give you chiral product. Now, last one, if you check this carbon atom, child, what you can see it contains 1 H, 1 methyl, 1 ethyl and 1 substituted methyl. That means even this can give you a chiral product. That means when this 2-methylbutane on monochlorination you will get 4 products. Out of 4, 2 of them will be non-chiral but remaining 2 will be chiral compounds. That means your correct answer has to be B. Is it clear, child? Let us take the next question. I think so. Now, over here, child, what you have got? You have got sodium cyanide and you have got halide. That means basically it is a nucleophilic substitution reaction where your halogen will get replaced by cyanide. That is very clear. That means your halogen will get replaced by cyanides. That is clear. Now, in our compound there are 2 halides, one is iodide and one is chloride. But you should know one thing very clearly, child. Your chloride what you have got over here is an alkyl halide and what you have got over here is an aryl halide. Now, when you talk about the reactivity, child, do aryl halides are getting involved in, halogen is involved in resonance with benzene? That means over here they will be less reactive as compared to alkyl halides. So, whenever if you are doing a treatment with sodium cyanide, your alkyl halide will get substituted, not aryl halide. That means, as per the case, your chloride only should get replaced by cyanide, not the iodide. And I think so the most correct option what you can see is D, where you can see your iodide is not changed, your chloride has been substituted. That means your correct answer is D. I hope this is clear, child. Let us take the next question what we have. Now, child, if you check over here, we have got over here a reaction where chloride is getting replaced by OH, since you have got aqueous. So, I think so it is a substitution reaction. Is it clear? Now, the question comes is, when you talk about substitution reaction, basically there are two substitution reaction what we are discussing in as per the syllabus. One is SN1 and one is SN2. Now, the question is, if you see your starting material, is it nothing but a tertiary carbon, because it is attached to 3 carbon atom directly? Yes. And what do you know about tertiary carbon atom? Please wait. Now, if you know this two mechanism, which substrates are best suited for SN1? I think so it's a tertiary alkyl halide. Yes. Whereas for SN1, if you remember, it's a backside attack, and for a backside attack your substrate should be as small as possible. So, methyl halides are the best substrate, even your primary alkyl halides are best substrate. But as per our question, if this is given tertiary, that means tertiary can be best substituted by SN1 mechanism. Now, what do you know about SN1, child? If you remember, whenever SN1 mechanism takes place, the product obtained contains two different stereoisomers in terms of 50% retention and 50% inversion. That means what you get, nothing but you get a enantiomer of the product. That means you will get nothing but a racemic mixture, and that is why in SN1, child, if the starting compound is an optically active, the product obtained would be an enantiomer. Is it clear? I hope this is clear with you. Next question, let us see what it is. Now, here on the next question, they have given us which one of the following compound undergoes even reaction most readily. Means they are asking which will undergo elimination fast. Now, child, before we start again in elimination, as per our syllabus, we have got a basic elimination reaction as E1 and another one is E2. Now, child, you should remember one thing, that for both the reaction, yes, the reactivity order is what? Your tertiary alkyl halide is more reactive than a secondary alkyl halide, and secondary alkyl halide is more reactive than your primary alkyl halide. That means, as per our discussion, let us see over here. Can I tell that this is a tertiary halide what you have got? Here it is a primary halide what you can see. Here again you have got a primary halide which I think so you can see very clearly, and it is again a tertiary. That means one thing is clear, which will be not that reactive. Yes, your primary halides are not that great to show elimination reaction, but your tertiary is best. Now, in tertiary also again we have two cases. Yes, so we have to go for another parameter which is called as reactivity order towards the leaving group. So, leaving group ability says that your alkyl iodide will do better elimination reaction as compared to alkyl bromide. Your alkyl bromide will do best reaction as compared to alkyl chloride. So, as per a reactivity order of the leaving group, your iodide do a better substitution, better elimination reaction what you have. Is the term clear? Fine. Let us proceed with the next question what we have. Now, question number 5. Now, as question number 5 says that this is one of the very simple concept which I think so you must have done somewhere, that we have got over here a carbon, yes, having a chlorine, one more chlorine and your H, and when a chloroform is kept in open air, yes, that is also in presence of light, what will happen? You will have your loss of H and Cl, and what will happen? Your carbon will get combined with that oxygen to form a phosgene. It's a phosgene gas, which is poisonous, and you will get your byproduct as HCl out. Now, since there are 2 oxygen, I need to balance this by 2, your balance by 2, and your byproduct also will be 2 HCl. Now, the question says that when you want to carry out this reaction, which take place, but what is the condition? I think so the condition is light, and I think so out of this option you can see light and air, because from air only we are going to get that oxygen. Is it term clear? So, remember one thing, this is the reason only why chloroforms are always kept in dark colored airtight bottles. Otherwise, what will happen? Your chloroform will become impure while formation of phosgene gas in a pure chloroform. Fine. Let's take the next question. What we have, child? Now, here what they have given, child, an organic compound, yes, C4H9Cl on a reaction with sodium diethyl ether, it gives you an hydrocarbon, which on monochlorination gives only one chloro derivative. Now, my question to you is very simple again. Now, which is the reaction what they are telling? Suppose if I have got alkyl halide, and when I treat this with sodium, correct? I think so you all know that over here you require 2 molecules of alkyl halide, correct? And basically what will happen, 2 moles of sodium would be required. Will I get nothing but over here and alkane formed, and which would be of course a symmetrical alkane, correct? And this reaction what we study is known as Wood's reaction. Is it clear, child? Now, the question is what? This compound on monochlorination gives only one product. Now, the question is only one product. Now, just use one common logic. That means the alkane what you have got should have only one type of hydrogen, correct? Let's come to the example. Now, the option A is tert butyl chloride. Now, the second option what you have got is sec-butyl. Now, how do you write a sec-butyl, child? We have done on a second carbon atom you will have Cl and you will have CH3, CH2, CH3 and CH. Now, if you see the next situation is isobutyl. Now, how do you write isobutyl? It's nothing but 3 carbon atoms. Second position have got methyl and then you have got Cl. Again you will put CH3, CH and CH2. Now, my question next is N-butyl. Now, how do you write N-butyl? All 3 carbon atoms, sorry 4 carbon atoms straight line you have Cl. Here you have got CH3, CH2, CH2, CH2. I think so this is nothing but option D. Now, my question to you is, suppose all these reactions are coupling, well, the Wurtz reaction is a coupling reaction. So, when you double it and when you double it also, that is B, C, D, you will have got many different types of carbon atoms having hydrogen, but only this compound if you see, let us double it. So, when you double it, what are you going to get? CH3, CH3 and CH3. Now, this compound only gets combined with another CH3, CH3 and CH3, and due to that sodium and Wurtz reaction they will get coupled, and after coupled you will see all 3 hydrogens, all three of methyl groups. If you see there are 18 hydrogens and all hydrogens are of one type only, and that is why only one chlorinated product what you can get from is option A. That means the correct answer for this is A. I hope this is clear. Let us proceed with the next question, child. Now, chlorobenzene can be prepared by reacting aniline with. Now, I think so you can't prepare chlorobenzene directly from aniline, but yes, you can prepare it via diazonium salt. Now, basically what is a diazonium salt formation? I think so we have done in the past. I think so I have got an aniline unit. This is aniline. Now, treat this aniline with Na, NO2 plus HCl. Now, what happens because of this? It basically forms nitrous acid and along with that some amount of HCl. Now because of that, what are you going to get? You will be getting nothing but diazonium salt formation. That means this reaction is known as diazotization. Now after this, child, when you start treating this with cuprous chloride in HCl, what happens? From here your N2 gas will lost, from here your Cl and H will get lost. Will I get nothing but over here a chlorobenzene as the product form? And I think so this reaction is one of the well known reaction called as Sandmeyer reaction. So the correct option for this can be, first your aniline has to be treated with nitrous acid, which is the first step, followed by treatment with cuprous chloride is the second step, and I think so the correct answer for this MCQ can be D. I hope this is clear, child. Let's proceed with the next question. Yes, which will give white PPT with silver nitrate. Now whenever if you have got a silver salt, it's very clear, child, that it will be having what? A formation of AgCl, and it will lead to a formation of a carbocation. So let's simply just remove the Cl. Now once if I remove the Cl, will I get nothing but over here a plus? If I remove the Cl, will I get over here a plus? And if I remove the Cl, will I get over here a plus? Now my question is, out of this three, which carbocation you think is very stable? I think so option A is a very stable carbocation, which is allyl carbocation due to resonance. Even C is also correct because it's a benzyl carbocation, which is again a resonance stabilized. Now only the one which is there, it's a phenyl carbocation, which is highly unstable. That means if Ag nitrate, that is silver nitrate, has to react, I think so there are two options to react, one is A and one is C, and that's why white PPT will be obtained with Cl and silver will be because of both option A and C. So the correct answer for this MCQ is both A and C. I hope this is clear. Let's proceed with the next question, child. Now, nucleophilic substitution reaction of optically active alkyl halide will give a mixture of enantiomer. I think so we have discussed in the previous examples also. Whenever if you get a mixture of enantiomer, that means that mechanism has to be SN1, correct? So the first statement is correct, maybe probably a nucleophilic substitution on optically active alkyl halide gives a mixture of enantiomer. Now second point, the reaction occurs according to SN2 mechanism. I think so this is wrong because in SN2 mechanism, child, you get only one product with the 100% inversion in a configuration. Yes, and that's why the first statement is correct, but the second statement is false. So as per the discussion, I think so assertion is correct, but reason is not correct. So your correct answer is D. I hope this is clear, child. Let's take the next question, child. Yes, now this is one of the very good question, child. You have got an alkene with an HCl. I think so it's a Markovnikov addition rule, but before Markovnikov, let's see the mechanism how Markovnikov works. So here the first step is, let's take an example. I have got over here a cyclic ring, which is a benzene, having some bonds like double bond is over here. Now first step, I think so alkene likes to undergo electrophilic addition. So first electrophile is this. So what will happen? Here this carbon will take the proton. So what will happen? Over here you will get a benzene with this carbon atom having a plus charge because proton is added over here. Now why we have taken this carbocation as a stable? Not stable, but we have taken this. Why? Because you can have hydride shift over there. That means it's a carbocation rearrangement. So what should be your answer, child? You will get a benzene. Yes. Now what will happen in this case, child? You can have a hydride shade, and after hydride shade you will get more stable carbocation. And now last finally, child, you have got Cl minus ion in the solution, which you can see. Will it can get attacked to this position? Correct. So what will happen? You will get nothing but over here a benzene ring, and your Cl will get attached to this carbon atom, which is resonance stabilized. Hence the correct option as per what is the option mentioned to us is the option B. I think so this is an example of carbocation rearrangement. I think so you are aware about this. Yeah. Let us proceed to the next question, child. Now, here child we have got SOCl2 and pyridine given in the reaction. Now, what is the use of SOCl2? I think so it is used to convert your alcohol to an alkyl chloride. That means SOCl2 reaction is one of the best method to convert alcohols to chloride. Now, here in our example we have got alcohol and other one is ether. We know that SOCl2 will not react with ether. So, ether should remain as ether only. So, here you can see here it has been modified. So, this cannot be answered. Here the Cl has got substituted, that is not possible. Over here this is also not possible. So, only one answer what I can see is the correct one, because your OH will get replaced by Cl. So, correct answer is A. I hope this is clear. Let us take the next question. Now, here among the following compounds which can be dehydrated very easily. Now, if you remember child, your dehydration of alcohol, I think from the mechanism situation, the first step is protonation of alcohol, correct. Now, the second step is loss of water molecule, due to which C plus is formed. That means a very simple situation child. From over here if you remove that OH, will I get a primary carbocation? From this when I remove OH, will I get a tertiary carbocation? From this when I remove this OH after protonation, will I get secondary carbocation? After loss of that water molecule due to proton, you will get a primary carbocation. Now, out of this so many carbocation child, this one is a primary carbocation, this one is a tertiary one, this one is a secondary carbocation, and this is a primary. Now, they have asked who will undergo dehydration very easily. Now, dehydration, rate of dehydration, basically it is an elimination reaction. So, it will be tertiary alcohols are more easily to dehydrate as compared to secondary. Secondary is more easy to dehydrate as compared to primary, and that is nothing but due to carbocation stability. And I think so as per the discussion, your answer C has to be correct. I hope this is clear child. Let us proceed with the next question. Now child, if you check over here, an unknown alcohol is given to you and it is treated with Lucas reagent. Now, Lucas reagent is used as a laboratory test for alcohol, mind it well. Now, to determine whether the alcohol is primary, secondary or tertiary, correct, which I told. Which alcohol react fast and by which mechanism? Now, answer is very clear. First of all, if you remember Lucas reagent, yes, your tertiary alcohol reacts very fast with Lucas reagent if you remember. Secondary will require 5 to 10 minutes and primary alcohol will not react with Lucas reagent at room temperature. That means if they are telling it reacts fast, that means it is very clear that they are talking about tertiary alcohols only and they are not talking about secondary. So, now my option can be either B or either D. Now, another important thing, since this reaction is what? If you check, this reaction is of this type child, alcohol reacts with an HCl in presence of anhydrous ZnCl2. I think so this is only known as Lucas reagent, correct? Now wait. Over here what happens? Your water molecule is lost. You get your compound as RCl and water is a byproduct. Now wait. If you remember child, this reaction follows SN1 mechanism. Yes, again the steps will be same. The first step will be protonation, then water molecule will be lost, you will get a carbocation. So, that mechanism can be SN1 and not SN2. So, your correct answer in this case is B. I hope this is clear child. Let us proceed with the next question. Now, here child, salicylic acid is prepared by using Riemann-Tiemann reaction, by treating phenol with. Now, basically in Riemann-Tiemann reaction, what do you get? If you remember child, when a phenol is treated with chloroform, and base like KOH or NaOH, it gives you salicylaldehyde. It's a salicylaldehyde as the product, correct? But there is one more point given to you, child, if you remember, that when a phenol is treated with carbon tetrachloride and a base NaOH or KOH, instead of salicylaldehyde, it is going to form salicylic acid. So, over here if you see what they are telling, Riemann-Tiemann reaction, they want to prepare salicylic acid, so it has to be carbon tetrachloride. Now, carbon tetrachloride you can see over here and with NaOH here. So, your correct answer has to be C. I hope this is clear, child. Let us take the next example. Now, here what has been given to you? Identify the reagent need to carry out the following reaction. Now, over here, child, if you see, it is a phenol and it is getting converted to one molecule, and I think so we have studied this molecule in the syllabus as benzoquinone. Now, question is what? If you see over here, what you can see, your H has been removed and O has been added to a process where your hydrogen is removed and oxygen is added. I think so we call it as oxidation, and I think though out of this reagent only one condition which you can see is an oxidizing agent, and I think so this should be the correct answer. This is nothing but one topic which we study in our syllabus is oxidation of phenol. I think so this is clear. I hope the next question will be again what? Let us see. Yeah. Now, over here what they have given, child, what amount of bromine will be required to convert 2 grams of phenol into 2,4,6 tribromophenol, correct? Now, basically, do you remember, child, what is this reaction? I think so the reaction is, if you take a phenol unit, and when you treat this with bromine, correct? What is the product obtained, they are telling? The product obtained is nothing but 2,4,6 tribromophenol, and along with that the byproduct obtained would be obviously HBr. Now, the question is what? Since this reaction is forming tribromination, that means the reaction must be taking place in water. Point number 1. Point number 2, the ratio in which they react is what? 1:3 moles. This is important, which we have discussed. That means now let us see how we use this concept to explain our problem. Let us see over here what it is. Now, let us first of all calculate, yes, let us calculate the molecular weight for this compound. Now, phenol has got something called as C6, H5 and OH. Yes. So, carbon contains carbon atomic weight is 12, atomic weight, and then you have to 6 times plus 5 for hydrogen plus 16 for oxygen and plus 1 for another hydrogen. I think so this comes down to, I think so, if you calculate, it's 12 6 are 72, 72 plus 5, it's 70, okay, we will do right also that, 72 plus 5. So, can I take that once? So, it makes us 6 plus 16. So, this total comes down to 78, and 78 plus 16 will give me 94, correct? Now, listen, over here bromine, now one bromine has got mass 80, but like that we have got over here Br2, it will be 160, and that 160 multiplied by 3, I think so the answer should be somewhere, how much? It's 480, is it correct? So, let us now take the calculation. What they are telling, how much gram of a bromine would be required? So, now listen, since 94 grams of phenol requires 480 grams of bromine, correct? Therefore, 2 grams of phenol will require what? 480 multiply by 2 upon 94. And I think so when you will calculate this value, it comes down to very simple, it is 10.22 grams. That means the correct option what you can see as per the script or as per the MCQ is B. I hope this is clear, child. Yeah. Let us take the next question what we have. Over here now the question given to you is very simple. Which among the following is the most acidic? Now, before we start this acidic concept, you should know one thing. When you compare a phenol compounds with alcohol compounds, obviously phenols are more acidic than alcohol. So, one thing is very clear, you have got alcohol over here, you have got alcohol over here. So, they will be the least least acidic. So, I can cut this. Only two options are left out, one is A and one is D. What is the gap you can see in both of them, child? Over here you have got one extra group called as chloro. Now, question is, chloro group shows minus I, and minus I increases the acidic strength, and that is why your correct D should be the answer, because D would be most acidic in nature. Is it term clear? Let us proceed with the next question, child. Yes. Now, child, in this question if you see, the ether that undergoes electrophilic substitution reaction. Now, basically just tell me one thing, child, which compound undergoes electrophilic substitution reaction well? Yes, it is nothing but a benzene molecule, correct? Now, out of this 4 example, if you check, yes, you can see benzene, I think so over here only, correct? So, fine, your correct answer is B. There are some silly mistakes what you can see. 1, here it has to be 5. Yes, here it has to be 3, only this is a problem, but we know the answer is benzene only likes to undergo electrophilic substitution. So, your correct answer is B. I hope this is clear, child. Fine. Now, let us take the next question. Now see, in the next MCQ what has been given to you, phenol is treated with chloroform plus NaOH. Now, this is one of the very common reaction called as Raymond-Tymon reaction. Now, what happens when a chloroform is treated with NaOH? And I think so we have discussed in a class, child, it is going to give you an electrophile, and that electrophile will be called as dichlorocarbene, and which will be the one to attack a phenol. I think so is an electrophile. So, what I have asked, the electrophile involved in is dichlorocarbene. So, your correct answer is this. I hope this is clear. Let us see the next question what you have got on the screen. Now, what I have given, child, the compound that is most difficult to protonate. Now, what do you mean by protonation? One simple thing, whenever if these compounds are treated with acids, H plus ion, so over here do you have got a lone pair present over here to get protonated? Yes. So, in each and every example your protonation can take place on oxygen well. Is it clear? But out of all of them, one of the compound is least available for protonation, and I think so the answer has to be option A. The reason is very clear, child, because you know that this lone pair will get involved in resonance with benzene, and once if it gets involved in resonance with benzene, the lone pairs are less available for a proton to abstract, to accept. In other term, the most difficult compound to get protonated is option A. I think so this is clear to you, child. Let us proceed with the next question. Now, child, this is another question where what has been given to you? I think so excess of HI is given to you, and I think so here you have got ether. Yeah, I hope it is clear. Now, when you talk about the situation of ether, let us write. We have got pH, we have got CH2, we have got O, we have got a benzene unit, and you have got OH. Now, wait, before we start anything, can I tell that it is an aromatic ether? And kids, I have given you already the logic that whenever if you have got an aromatic ether and when it has been treated with HI, it is very clear that your compound has to be a phenol as the compound. But let us see how we get that. Let us try to discuss. Over here now, child, if you see over here, the lone pair gets involved in resonance with the benzene. That means this bond is strong to break. So, it is a strong bond which does not be broken easily. So, which bond can be broken easily? I think so this one. So, here you will have got iodine and here you will have H. So, the compound obtained is benzyl iodide and you will get nothing but benzene with 2 OH groups. Is it clear? So, I think so the correct answer as per the discussion would be B. Now, maybe some of the kids would be even thinking, sir, will this HI will react with OH? I think so no, because HI reacts with alcohol but not with phenol, because again they are got involved in resonance. So, they cannot be substituted, remember that. So, your correct answer is B. Let us see the next question what we have. So, kid, let us see the next question what we have on the screen, and I think so in this question what you can see very clearly that this is one compound given to you where there are two functional groups, one is aldehyde and one is double bond. Now, here they have given H2PT, here they have given sodium borohydride. Now, both of them are used for reduction, but one thing is very clear that your sodium borohydride do not attack double bond, whereas H2PT attacks both the group. That means one thing is very clear, for both the cases there are different products. That means your option C is cut, because you have got same product for both, can't be possible. Option D is also not possible. Now, the question is what? If you see option product A, your double bond also will get reduced and even aldehyde will get reduced. So, double bond after reduction, double bond, wait, let us write, nothing will happen to ring. Your double bond will become single bond and your aldehyde will get converted to a primary alcohol. That means over here the product obtained what you would be having is this, where both the groups will get reduced. So, your option A, what I can see is only one which is matching, correct. So, the correct option for this MCQ what you can see is option B. I hope this is clear to you, child. Yes. So, let us proceed to the next question what we have. Now, see over here, question number 23. In the following reaction A is what? Now, I think so this is one of the very common reaction, child. We have got ethyl magnesium bromide, correct, and we have got over here a CH2 with an oxygen. Is it clear? And this compound on further hydrolysis will give you what? Now, child, if you remember, this question is of something related to triangle O, which is called as cyclic ether, and if you remember, these compounds are called as ethylene oxide. Now, I have given you one logic. If you see, I think it's a reaction of a Grignard where both of them will get added, point number 1. Yes, and the product obtained would be primary alcohol. Let us try. Over here, how many carbon atoms you have got? 2. Over here also, how many carbon atoms you have got? 2. And will it get added to give you 4 carbon atom primary alcohol? Is it term clear? I think so. Let us check first example. Here you have got an aldehyde, which cannot be the case. Here again it is an aldehyde, which cannot be the case. So, your answer can be primary alcohol, that is right. Your answer can be primary alcohol, that is right. But the question is, the number of carbon atom will become 4. That means over here if you see, there are only 3 carbon atoms. Here if you see, there are 4 carbon atoms. So, your correct answer has to be yes. Your B is the correct answer, not C. I hope this is clear. In the lecture also we have discussed this question. Yeah. Let us proceed with the next one. Now, the next question what you have got on the screen is phenol, yes, is allowed to react with bromine in carbon disulfide and in aqueous solution. Now, question to you is, child, phenol on bromination has got 2 scenarios. One is polar solvent and one is less polar or non-polar solvent. Now, what happens? In a polar solvent, child, where bromonium ion formation is maximum, so it will give you 2,4,6 tribromophenol as multi-bromination product, and in case of non-polar solvent, monobromination takes place where you get ortho and para bromophenol. So, let us see over here what we have. The second point is aqueous solution, that means it is a polar solvent. Now, in the second case you should have 2,4,6. Now, 2,4,6 I think so you have got only in one option which you can see. Is it clear? I think so in none of the cases you have that. Again, if you see in case of non-polar solvent as a case number 1, what is given reaction number 1. Now, in that you get always a monobromo product as ortho and para. So, here even this condition is also correct. So, the correct option for this MCQ what we have is option C. I hope this is clear, child. Let us proceed with the next question, Bacha. Now, here the question is what? An optically active organic compound has a molecular formula C5H12O, which I think so you can see. This compound X on oxidation with chromium trioxide gives an achiral compound. What is your product X? It's very clear, child. It's an oxidation reaction, but before starting this oxidation, I can tell you there is a logic to be solved this. What is there mentioned? Optically active compound is used. Now, if you see out of 4, yes, only one compound which I can see is optically active, which is this one. You can check achiral carbon. If you check, this is not an optically compound. This is also not an optically active because both the groups are same. Even this is also not an optically compound. That means this question need not to be solved as what is given. Use the logic that they have told that optically active carbon. Now, I think so optically active is only one case. So, the correct option for this option is A. Correct answer for this MCQ is A. I hope this is clear. Let us see the next question. Now, here child what they have given? The best reagent to convert pen 3 into all into pen 3 into 1. Now, if you see a compound child properly, there are 5 carbon given to you. Second position you have got an OH and third position you have got a double bond. Now, which is a compound which will be used to convert this compound into this compound, which is 5 carbon atom. Second position you have got O and double bond is there. Now, that means what you can see, your alcohols are converted into an ketones, that means it is an oxidation. But now, if you see alkaline KNO4 and alkaline K2Cr27, both of them can oxidize your double bond also, and since my double bond remains as it is, that means these cannot be the answer. Now, even chromic anhydride in glacial acetic acid, but in that case also child, if you see the most prominent option, what you can see is nothing but, because pyridinium chlorochromate is a mild oxidizing agent which will oxidize your primary alcohol to an aldehyde, secondary alcohol to ketone, but will not oxidize your double bond. So, in this case the most appropriate answer is PCC, which I think so the correct answer in that case is D. I hope this is clear, child. Let us take the next question, child, what we have. Now, here this is one of the very common question. Let us see what it is. See, I have got over here an alkyne which contains a terminal H. That means you have got a terminal alkynes which are acidic. So, it can react with the base very easily. So, what I will do is I will put over here for you CH3, CH2, CH2, C, triple bond C with H. Now, when you treat this with sodamide, I think so you should know one thing, that your acidic H will go lost with amine part, which is why you get an ammonia, and you will get now sodium salt. Now, how to write that sodium salt? It is nothing but the same one. Here you have CH2, you can see C, triple bond C. Now, when H is lost, you get a conjugate part, conjugate base, and along with that you will have Na. This is the first part. Then you are telling that this has to be treated with what? N-propyl bromide. Now, when you treat this with N-propyl bromide, what happens? I think so you understand one thing, alkyl halide likes to undergo nucleophilic substitution reaction. So, here this is that nucleophile who will attack this, and your Na and Br will get lost. So, you will get the answer as CH3. Okay, I will not write over there because it won't be able to fit. I will write down. You have got CH3, CH2, CH2, C triple bond C, and then you have got that propyl part, which is CH2, CH2, CH3. Now, only the last part. What is left out in this? Yes, last part is nothing but this compound is to be treated with HgSO4 and H2SO4. What will happen? Generally, this reaction is where your alkynes gets hydration, and where you get a ketone. So, over here when you apply the concept, according to Markovnikov. Yes, but it's a symmetrical alkyne, you can add anywhere H, you can add anywhere O. So, the compound obtained would be what? How many carbon atoms are there? 1, 2, 3, 4, 5, 6, 7 and 8. So, can I put 8 carbon atoms over here? Yes, and you can see your ketone can be either side. So, anywhere you want you can put a ketone. So, here 1, 2, 3, 4 I can put over here a ketone and your H will be there. So, I think so correct answer as per the situation would be this. I hope this is clear, child. Sure. Now, here what this reaction says that a hydrocarbon X is mentioned on treatment with ozone followed by reduction, yes, of ozonide gives Y. This Y compound gives both your Tollens test positive, which I think so you can see very clearly, and even yellow PPT with iodoform. Now, I think so both these reactions are to be shown by whom? Now, see, we know that Tollens reagent is shown by aldehyde, that is very clear. That yellow PPT is shown by generally ketones, which is nothing but alkane 2 ones, correct, or alcohols which are 2 ols, and other 2 compounds like exceptional aldehyde and exceptional ethanol. Now, wait, before we start anything, let us first of all try to use some logic. Now, during ozonolysis, I think so we have got over here to break a bond and put both the sides O. In this case also, when you start to break the bond, we get both the sides O. Again, when you break the bond, I think so you get both the sides O. Again, when you break this bond, you get both the sides O. Now, the question is what? If you check, I think so this option A has got ketone and aldehyde form both. In this case, I think so you have got a ketone and a ketone. In this case, I think so you have got both aldehyde and aldehyde, and in this case again you have got both aldehyde and aldehyde. Now, one thing is clear, as per our question you can see both ketone can give iodoform test, but cannot give Tollens, but here they are telling Tollens is also positive. So, this cannot be the answer. Now, here I think so both the aldehydes are there which can give Tollens test positive, but which will not give iodoform test. So, this is also not possible since our question says both will be there. In this case again you have got both aldehydes. So, aldehyde will give Tollens test, but not iodoform. Again this cannot be the answer. So, only one answer which you can see, that after breaking of this compound, child, the molecule will look like this, child, where you have got a bond sorry, here you have got a molecule where after ozonolysis it is going to give you nothing but a methyl ketone group, and it is an aldehyde. So, this will give Tollens test positive and this will give iodoform test positive, and I think so the correct answer for this MCQ is option A. I hope this is clear. Let us move to the next question what we have. Now, here what they have given, what would be the major product in the following reaction. Now, I think so they have mentioned over here it is a lithium aluminum hydride. Now, basically lithium aluminum hydride, first of all, do not attack double bond. So, first of all, wherever there is a double bond, as it is kept would be a most probable answer. So, first you have seen that here you do not have a double bond, so this cannot be the answer. Here there is no double bond, that means this cannot be the answer. So, your correct answer has to be either A or either C. Now, the next question. Shall we know that lithium aluminum hydride will change your will change your ketone to secondary alcohol, and even it will convert your carboxylic acid to a primary alcohol. Now, you can see over here you have got secondary alcohol and a primary alcohol, which is more appropriate. In this case you can see alcohol is there, but acid has not been reduced. So, this cannot be the correct answer because lithium aluminum hydride will reduce both of them. So, your correct answer is A. I hope this is clear, child. Let us take the next question. Now, what I have mentioned, child, which of the following will give a racemic mixture reduction or with treatment with sodium borohydride followed by acid workup. Now, before we start anything, I think so you should know one thing, that what sodium borohydride will do. Now, when you see what a sodium borohydride will do, over here you can see the compound what you have got an aldehyde will get changed to a primary alcohol. In the second example, child, no reaction because sodium borohydride do not reduces carboxylic acid. In this case, child, you can see your sodium borohydride will convert your ketone into secondary alcohol, and in this last case, your sodium borohydride will convert your ketone into secondary alcohol. Now, my question is, first of all, what they have told, it will give you a racemic mixture. Now, for a racemic mixture to form, the compound should contain chiral carbon atom. Now, in the first example, you are getting product primary alcohol, but you are not getting chiral carbon. That means this cannot be the answer. In this, we do not have a reaction only, that means this is not possible. In this case, we have got alcohol, but since both the sides groups are same, that means this also is not giving me chiral carbon. Is it clear? That means this cannot be the answer. Yes, but now last example, if you check, where this is a chiral carbon, it has got 4 different groups. So, this will be the product formed where it will be a racemic mixture of pentane to all, and I think so this is the correct answer of the MCQ what we have. I think so this is clear, child. Let us see the next question, Bacha. Now, here what is the statement they have given? See, a content of 3 bottles were found to react. First bottle, neither with Fellings and neither with Tollens. Second has only with Tollens reagent but not with Fellings, and last reacts with both Tollens and Fellings. Now, I think so Tollens and Fellings reactions test are used for aldehydes, if you remember, and one important conditions, if you remember, in Fellings solution, aromatic aldehyde, that is benzaldehyde, do not show Fellings test. This is a concept. Let us see first of all. Now, if they contain either ethanol, which has been mentioned by acetaldehyde, propanol mentioned as acetone, and benzal means benzaldehyde. Now, bacha, statement number 1, we will just check that. Statement 1, bottle 1 or the statement 1, neither with Fellings nor with Tollens. That means this is such a compound which do not show both the tests. Now, see, benzaldehyde is an aldehyde, so it can show Tollens test. Benzaldehyde is aldehyde, so it can show Tollens test. That means both can be the answer, but ketones cannot show neither test. That means in this case, the statement what they are giving is neither reacts with Fellings, neither react with Tollens. That means the statement 1 has to be does not react with both. So, here benzaldehyde reacts with what? Tollens. That means this cannot be the answer. So, your correct answer can be most probably either C or either D, because ketones do not show both these tests. Now, come to the second statement, only with Tollens but not with Fellings. Now, out of these two statements, child, which does not react with Fellings? I think so benzaldehyde does not react. So, benzaldehyde out of these two options, if you see, is over here. That means even this answer is incorrect. So, your correct answer in this case is C. I hope this is clear to you, child. Yeah, let us proceed to the next question. Now, the Cannizzaro reaction is not given by. Now, if you know Cannizzaro reaction is not shown. Achha, first of all, Cannizzaro reaction is shown by which compound? It is shown by a compound which contains? No. What it is? Cannizzaro reaction is shown by a compound which do not contain alpha hydrogen. Now, if you see in this example, child, when you see the question given to you is trimethyl acetaldehyde. Now, structure for trimethyl acetaldehyde is this one. Now, the second example what you have got is acetaldehyde. Now, the next example what you have got is benzaldehyde. And the last example is formaldehyde. Now, the question is what? Cannizzaro reaction is not given by. Now, first of all, Cannizzaro reaction is shown by those compounds which do not contain alpha. I think so you do not have alpha, that means this will show Cannizzaro. Even aromatic aldehydes do not contain alpha, so this also will show Cannizzaro. Even this compound, if you check, there is an alpha carbon without any H, so even this also can show Cannizzaro. If you check, this contains alpha hydrogen, that means this compound is the one which will not show Cannizzaro, but it can show aldol condensation, correct? So they are asked, not given. So your correct answer is B. I hope this is clear. Let's take the next question what we have. Now see what they have given. Treatment of propionaldehyde with dilute NaOH. Now before we start anything, let's put it over here. Is it the propionaldehyde what you have got? Now first of all tell me, when you treat this with a base, just tell me one thing, what happens? The first thing what happens is, whenever aldehyde which contains alpha H treated with a base, obviously it will like to undergo aldol. So this is an aldol condensation. Now point number 2, what is a product? What is the product? The product would be, of course, of aldol would be beta hydroxy aldehyde, correct? Yes. So now let's try to eliminate without writing any reaction. Now see, that means your product should have two group, hydroxy group and aldehyde group. Now when you see over here, I think so you can see over here this group is like an ester which look like, yes. So this cannot be the answer, correct? Now the next important part what you can see is over here. How many carbon atoms are there in this picture? 1, 2, 3, 4 and 5. Now I don't know if you remember or no, but is this a reaction where in aldol it's a condensation of two molecules, where if 3 carbon atoms are there, it will be into 2. That means the product should have 6 carbon atom product, and I think so you don't have a 6 carbon atom in this case. So even a D option is also incorrect. Now the last option, if you write the molecule C properly, does your C molecule look like this? CH3, CH2, CH with OH, and it's nothing but CH2 with a CH2 and aldehyde. And let's write the compound number B also in this. CH3, CH2, CH with OH group with CH having one methyl group and having CHO. Now my question to you is, child, whenever aldol condensation takes place, you always get beta hydroxy. Now over here, child, check. I think so it's a beta, it's alpha, beta and gamma. Have you got a gamma hydroxy aldehyde? But in aldol never we get gamma. In aldol we always get some beta hydroxy aldehyde. That means even this option is also not possible. So your correct answer is B. I hope this is clear. Let's see the next question what we have. Now your next question given to you is something like this, child. I have gotten carboxylic acid, yes, which is very simple. Let's write, which is a propionic acid. Now treat this propionic acid with chlorine in presence of red phosphorus. I think so, child, if you recollect, this is nothing but an HVZ reaction. Now what we know about HVZ reaction? It's an alpha halogenation. So what will happen, child? You will have H and Cl lost as HCl, and will I get nothing but alpha chloroacid, and I think so you have got a compound is 2-chloropropionic acid. Now what is the second step given to you? It's alcoholic KOH. Now what alcoholic KOH does, child? We know that it's one which indicates an elimination reaction. Now after elimination, child, you should get an answer alkene. I think so out of 4, answer is very clear, but still I will write this is alpha. Here from this you will have a loss of H. So will I get nothing but the answer as CH2 double bond CH with an acid. So your correct answer in that case has to be C. I hope this is clear, child. Let's see the next question what we have. Now over here, child, in this reaction what is given to you, I have got acetic acid, correct? Now treat this with lithium aluminium hydride. Now what does lithium aluminium hydride does? It reduces your carboxylic acid to an primary alcohol. So your answer has to be ethyl alcohol. Now this compound on further treatment with PCl5, not PCl5 will do. PCl5 is a chlorinating agent which will change your OH to Cl. So, will I get nothing but ethyl chloride? And last step, what has been mentioned? It's again nothing but alcoholic KOH. Now, bacha, you should know one thing. Again, it's an elimination reaction. Now, after elimination, I think so you should get alkene. Now, out of 4, I think so 1 alkene we already know is nothing but ethylene. But see what is a product. I think so we have got CH2, double bond CH2. That means this compound is known as ethene and the common name is ethylene. So, your correct answer has to be C. I hope this is clear, child. Let us take the next question. Now, here child, if you see, we have got one again a set of reaction given to you. I have got over here a carboxylic acid, correct? Now, treat this with SOCl2. Now, we know that SOCl2 does change your OH to Cl. So, we will get over here as acid chloride. Now, when this compound is treated, I think so this is nothing but my compound A. Now, when this compound is treated with benzene, I think so this reaction, if you recollect, it's an Friedel-Crafts acylation, where the product obtained would be a benzene ring containing your acetyl part. So, can I tell that acetophenone is obtained as the product B. Now, this compound B has to be treated with HCl. Now, this is one of the very common reaction where cyanohydrin is obtained. Yes. So, you have this as a delta positive part, this is a negative part. Here it is again a electrophilic center, here it is a nucleophilic center. So, your nucleophile will attack because aldehyde ketone likes to undergo nucleophilic addition and hence this O will combine with H. So, the product obtained is a benzene ring having C attached to CH3 and over here you have got OH and here you have got cyanide, correct. So, this is called as my cyanohydrin product, which is option C. Now, last step, this has been treated with water, that is hydrolysis, and we know that only one group has got a capacity to get hydrolyzed as in the case of our example, and it's an cyanide. So, what will happen? Benzene will have one group as OH, another group as CH3 and last group is carboxylic, because cyanide always on hydrolysis gives carboxylic acid. So, what should be the correct answer? I think so you can see carboxylic acid at two places, one is here and one is here, but the most appropriate answer what you have got is nothing but the option A. So, this is only nothing but your correct product. I hope this is clear, child. Let us proceed with the next question, child. Now, here what is mentioned? I think so we have got over here acetic acid, correct. Now, it has been treated with ammonia. Now, when it has been treated with ammonia and even heating is also done, if you see, will your OH will get converted to an amide? Yes. So, here the compound obtained would be acetamide. Is the term clear? Now, this compound on treatment with P2O5. Now, P2O5 is nothing but a dehydrating agent, child. So, will your O and H2 will get lost? Will I get nothing but the answer as cyanide obtained in this, and this cyanide is known as methyl cyanide or acetonitrile, and hence the correct option what you have got in example number this, where this is B product, and that is nothing but option C. I hope this is clear. Let us proceed to the next question, child. What we have again, it is a name reaction, child. I have got over here a benzene ring where you have got a carboxylic acid and a Br. This is my compound A. Now, the first step is treatment with SOCl2. Now, what SOCl2 does? It will convert your acid to acid chloride. So, the product obtained in this case would be, I have taken acid chloride, yes, and Br will remain as Br only. Now, this is nothing but my product B. Now, this compound on further treatment with ammonia. Now, one very common reaction what we know is what? You have got your Cl and this H get lost as HCl. So, the product obtained in this case would be nothing but what? A benzene containing a Br, and over here you will have got an amide group. Is it clear? So, this becomes your product number C. Now, last step. You have got one reagent which is Br2 plus NaOH, and I think so this is one of the very common reaction child called as Hoffman bromamide degradation, where your CO group gets removed, if you remember child. So, the product obtained in this case would be a benzene ring. You have got over here NH2 and you have got bromine. Now, if you check this molecule properly as option D, you have got bromine and amino group at meta position. So, correct answer as per the discussion has to be option D. I hope this is clear. Let us proceed with the next question child, what we have got on the screen. Now, acetone is treated with excess of ethanol in presence of hydrochloric acid. The product obtained is. Now, child, if you remember this reaction, it is what? Aldehyde ketone when reacts with the alcohol, it forms hemiacetal, and this hemiacetal when reacts with the second molecule gives you an acetal formation. Now, how to carry out this reaction? Let us see. I have got over here an acetone unit. Is it clear, child? And it has to be treated now with what? It has to be treated with ethanol in excess. So, directly I think so we can write the product, and the shortcut for this is what? Suppose if I have got ethyl alcohol 2 units. So, I have got 2 units of ethyl alcohol. Now, what you should remember is in presence of HCl, of course, what will happen? Remove oxygen and remove both the H's from this. This is a shortcut what we follow. So, the answer what you get is CH3, CCH3. Here you will have got O with C2H5. Here you will have O with C2H5. That means this is nothing but called as acetal formation. Now, what should be the correct answer? I think so as per the option, what you can see, the correct answer is B. I hope this is clear, child. Let us proceed with the next question. Now, child, what has been mentioned? And organic compound X is given to you with the molecular formula C5, H10 and O. This compound yields, means when it is treated with 2,4-DNP, it gives test positive. Is it clear? That means confirm this compound has to be aldehyde or this compound has to be ketone. Point number 1 clear. Now, what they are giving? The next step, this compound X gives negative response to Tollens test, negative response to Tollens test, negative response. That means this compound cannot be aldehyde. This compound cannot be aldehyde. That means this has to be only ketones. Now, there is one more. This compound even does not show iodoform test, negative. Now, basically when you talk about iodoform test, only 2 ones can show iodoform test. That means slowly what you can do is, now when you see that this compound cannot be an alcohol, that is clear. Now, when you see the next test, it is showing Tollens test. sorry, it is not showing Tollens test. Now, Tollens test is shown by aldehyde, so even this cannot be the answer. Now, the option left out only 2 ones and 3 ones. Now, we know iodoform test is shown by 2 1, but here it is telling that it tests negative iodoform test. That means, even your answer cannot be a pentane 2 1. So, your correct answer for this MCQ has to be A. I hope this is clear. Let us see the next question, child. Now, child, this is one of the very common question. I think so. Question number 41. I think so. We have got is nothing but diethyl. Sorry, I'll write once again this part. I think so. This compound, what is given to you, is nothing but CH3, CH3, and it's an OH. I think so. This is secondary alcohol, and secondary alcohol on oxidation, that's mild oxidation, what will happen? Your H will get lost. So, will I get nothing but over here as a ketone, correct? And the next step given to you is what? This is compound X. Now, whenever if you treat aldehydes and ketones with a Grignard reagent followed by hydrolysis, obviously the product obtained has to be an alcohol, correct? Now, wait, first of all, can I remove my option D because it's an alkene, what is given? Point number 2, when a ketone is treated with a Grignard reagent, your answer has to be tertiary alcohol only. Is it clear? Not only this, the number of carbon atom also can also be one more point. Yes, over here you have got 3 carbon atom. Grignard contain 1 carbon atom. So, when you add, will I get 4 carbon atom tertiary alcohol? So, now you can see N-butyl alcohol is primary in nature. So, this cannot be the answer. Isobutyl alcohol is also a primary. This cannot be the answer. So, your correct answer is nothing but your tertiary butyl alcohol. I hope this is clear, child. Let us take the next question. Now, here what they have given. When dimethyl cadmium is treated with acetyl chloride, the main product obtained likely to be. Now, first of all, how do you write an acetyl chloride? It's something like this, child, where they have given even a structure to you. Now, how do you write a diethyl cadmium? I think so, it's a C2H5 cadmium, and even the next C2, it's a dialkyl containing molecule. Now, I think so, you know, child, one thing. Your acid chlorides or acid derivatives like to undergo what? Nucleophilic substitution. So, this is a leaving group. We know this carbon atom is electrophilic carbon, this is nucleophilic oxygen. Now, when organometallic compound, when you talk, metals are always electropositive. So, the alkyl group is nothing but acting as a nucleophile. So, what happens? This negative part will attack to this carbon atom and your Cl will go out. Since we know that it is a dialkylating group, so 2 molecules will be required of this. So, your answer would be what? I think so, your answer would be, you have got a methyl with a carbonyl group, and another side you will have got something called as ethyl. Since it is a dialkylating agent, you will require 2 moles, and the byproduct obtained would be cadmium with 2 chlorines you must have got, in short, chlorides. So, the product obtained in this case is nothing but ethyl methyl ketone. So, your correct answer in this case is option B. I hope this is clear. Let us take the next question, child. Yeah, now this is a conceptual, child. During a Jidal's method, your nitrogen present is estimated in form of ammonia, child, and that ammonia only is been treated with known concentrated volume of an sulfuric acid, which has been back titrated by NaOH to find out the amount of ammonia obtained. So, in this case, child, your nitrogen is converted, yes, to an ammonia. So, your correct answer is ammonia. That is option B. Let us see the next question, child, what we have. Now, Lysagnis test for a detection of nitrogen will fail in which of the case? Now, before we start, I think so we should make it one thing clear. What is Lysagnis test? Now, Lysagnis test is nothing but where your organic compound, what has been given to you, let us say it contains nitrogen. Yes, it is heated with sodium metal, or in other terms you tell solid compound, organic compound and your sodium solid gets fused on heating. Now, after heating it forms a sodium fusion extract. And what is happening over here? Deliberately your organic compound is converted into inorganic. How? Let us see. Over here it is a sodium. Since when you have got a nitrogen in your compound, along with that there is a carbon, it will form sodium cyanide as the product. So, your nitrogen is deliberately converted into sodium cyanide. Now, my question is, for sodium cyanide to obtain you require 3 elements, one is sodium, one is carbon and one is nitrogen. And among the following, which compound will fail to give this sodium cyanide nitrogen test? And I think so in that case your correct answer has to be C, because here you have got nitrogen, you have got sodium, but from where you will be getting carbon? That means this compound will not show sodium fusion test for nitrogen. I hope this is the clear answer to you. Yeah, let us proceed to the next question. Now, here child, separation of an organic compound by column chromatography is due to. Now, you must have read it this in NCERT that column chromatography works on a property called as differential adsorption, because different components have got different adsorption capacity. That means over here different compounds have got different adsorption selectivity. Hence, the answer has to be your answer D. I hope this is clear, child. So, here I think so the questions what we have discussed are clear to you. Still, if you have any problem, you come down to branch. We are available over here to solve your doubts. I think so. Is it clear? Thank you very much.